Hello, class. I asked you to do the homework, and some people have not done so. So please complete this package as soon as possible and turn them in through Google Classroom. Don't email me. Today we're going to go over the entire package. I'm going to break them down into several different videos so you can just go find your answers accordingly. Question number 1. An unbalanced force of 12 newtons, so F equal 12N, and M equal 6 kilogram. We all know F equal MA. So A equal force divided by M, which is 12 Newton divided by 6 kilogram, is 2 meter per second squared. So it's B. Question number 2. A lamp placed on a table has a mass of 2 kilogram. If it has a weight of 20 Newton, so this is our table, and this is our lamp. The gravitational force, which is the weight, is 20 Newton. And the force the table exerts on the lamp is the opposite force, an equal force of Fg, which is Fn. Since they're balanced, Fn is 20 Newton, so it's C. Question number 3. Which graph best represents the relationship between the unbalanced force applied to a body and the body's acceleration? So we know F net equal ma. If it's unbalanced force, F net is not equal to 0, right? So if the acceleration increase, the force, unbalanced force increase, or the unbalanced force increase, acceleration increase. So they're directly proportional. And your answer is C. Question number 4. An object acting upon a constant balanced force, which graph best represent the motion of this object? So if you have constant unbalanced force, so F is increase, or A is increase, all right. So since we have a constant unbalanced force, so F equal ma. Remember, F and A, they're directly proportional, right? So if F is constant, your A is also constant over time. So your answer is D. D is the only one that shows A is constant. Question number 5. All you have to do is to graph, right? Label the axis of the graph with appropriate value for force and acceleration. So here, our force is independent variable, which is x. Our acceleration is dependent variable, which is y. So our x-axis is force. Let me put it on the side because I need to write a number there. Force in Newton. Then y-axis is acceleration meter per second square. Okay. Then you need to put your number down, right? So 0. So 0, and then I'll mark each one as 2. So 4 is right here. 8, 12, 16, and 20. And then the y-axis, this will be 2, 4, 6, 8, and 10. Okay? And now you plot force at 4, acceleration is 2.1, which is right here. 8 and 4, 12 and 6, 16 and 7.9, and then 20 and 10. And use the data on your graph to determine the mass. Show all calculations. So, okay, first of all, let's draw the best fit line. Sorry, I don't have a ruler. So if you have a ruler, you can draw a much better line. And as for calculation, F equal ma, right? So m equal force divided by a. You can pick any one because there is a linear relationship, directly proportional. So I will just use 12n divided by 6m per second square equal 2 kilogram. Number 6. In the diagram show surface A of the wood block has twice the area of surface B. If it takes F Newton to keep the block moving at constant speed across the table when it slides on surface A, what force is needed to keep the block moving at constant speed when it slides on surface B? So we all know here it says moving at constant speed, right? That means your F net is equal to 0. So if you draw a little free body diagram going forward, force should be the same as going backward force. And we know F equal ma, right? And the m, the mass, doesn't change. So it doesn't matter if it slides on top of surface A or surface B, your force that apply here should not be changed. It should be F. Assume that we did not consider the friction based on the different area. Okay, because the question does not talk about friction, so we just assume the friction will be the same. Okay. Number 7. Which graph best represents the relationship between the mass of different objects and the gravitational force? Okay, again, we have to have our formula. Gravitational force is the weight, right? Weight equal mg. The g is gravity. Gravity is always the same. The mass change So if the mass of object increase, your gravitational force also increase, so they are directly proportional. Your answer is D. Number 8. So first, part A, we need to draw the free body diagram. The weight, which is gravitational force, is 20 Newton. And then the normal force, which is the opposite force, is also 20 Newton. And the frictional force is 2.4 Newton. Okay? All right, that's just part A. There's nothing else acting on this block. Part B. All right, so here we are going to find acceleration of the block. Still, we're going to look at Fnet equal ma, and we're looking for A. So based on the diagram we have in part A, our Fnet is the frictional force, which is negative 2.4 Newton. Okay, reason why we have negative here is because now we only have one dimension, which is horizontal forces that we are comparing. And acceleration is a vector, so it is going to have a direction. And in the question, it tells us the block will be brought to rest by the frictional force in a distance of 10 meters. If we assume the 10 meter going forward, okay, that 10 meter that going forward is positive, so going backwards friction, it will be negative. All right? Okay. Negative 2.4 Newton equal mass. Mass, we can get them from gravitational force. Gravitational force is mg. So you use 20 Newton divided by gravity, you get mass. I'll just assume the gravity round up to 10. So your mass is 2 kilogram times A. And you divide 2 kilogram on both sides. A equal negative 1.2 meter per second square. Okay, number 9. A force of 50 Newton causes an object to accelerate at 10 meter per second square. So F equal 50 Newton. Cause an object to accelerate at 10 meter per second square. What is mass? M equal F divided by A, 50 Newton divided by 10 meter per second square is 5 kilogram. So it's C. Number 10. A car rolls down an inclined plane with constant speed. Okay, constant speed, that tells us Fnet is 0, acceleration is 0. Which arrow represents the direction of frictional force? Remember, frictional force is always the opposite direction of your motion. So your motion is right here going down, and D is the opposite, will be frictional force.